righty. Now, the first couple of sections of this chapter is all about graphing calculator. And I'm just going to tell you that right now. Talking about the inverse function or the logarithmic function. Inverse operations, and I'll talk a little bit about inverse operations. Let's take this first one right here. F of x is equal to 8x. F of x is equal to 8x. Now to find the inverse operation for f of x is equal to 8x, find the inverse operation of f of x is equal to 8x. The first thing we do is we change f of x to y. Make it, let's put our pinkies down and let's go back to elementary pre-algebra, algebra 1, and say y is equal to 8x. That's the first thing you do. Second thing you do is you solve for, is you switch the x and the y and solve for y. So y is equal to, y inverse is equal to x over 8. Okay? That's how you do any function. That's how you find the inverse. So, the inverse function of this function is y inverse is equal to x over 8. Now, both of you, I mean every one of you, I want you to get your graphic calculators out, and I want you to graph f of x is equal to 8x, and then I want you to graph x over 8, or 1/8 x. We're going to take our handy-dandy calculator, and we're going to graph y is equal to 8x. And I'm going to go down and I'm going to change the other one to dark. And we're going to change that to x over 8. And there's one function, and there's the other function. Now, you can't see it very well with this because you got straight lines, but you got one going this way, and the inverse is this way. Now what does that mean? That means that when you graph these two, f of x is equal to 8x. I'm going to use multiples of the denominator. Let's say we have 8 over x. Was it 8 over x? Yeah, 8 over x. So we can use -2, -1, 0, 1, 2. So -2, that'd be 16. -1 would be -8. 0 would be 0. 1 would be 8. And 2 would be 16. F of x is equal to x over, is it 8 over x?
It was x over 8.
Is it x over 8?
Yes, sir.
That is the wrong one before. X over 8?
Yes, sir.
Okay. I'm sorry. We just need to use multiples of the denominator then. and change these. I'm going to use negative 16, negative 8, 0, 6, 8, sorry, and 16. All right, negative 16 times 8 is going to be, what, 128? Somebody check my math. Negative 8 be negative 64, 0, 64, and 128. No need to check that.
Right.
Okay. Okay, now over here, x, y, negative 16, negative 8, 0, 8, and 16. What's negative 16 divided by 8? Negative 2, Hubert. Negative 8 divided by 8, negative 1, 0, 1, and 2. And what you see is a very steep line right here because you got bigger numbers. And here you got a very shallow or not steep line right here. So that's the inverse of this. Now you can really see it when you're doing a curve, and we're going to do that here in just a minute. But this one right here looks like this. However it looks, let's see, negative 16, negative 128, negative 8, negative 64. It looks something like this. And this one, negative 16, negative 2, looks something like that. Very steep, not very steep, which is the inverse. What's the inverse of steep? Not very steep. Okay? Now, let's move into a curve so you can actually really see the inverse. And that's a one-to-one function. We'll get to that in just a minute. Okay. Let's do this one right here. Let's do f of x is equal to negative x squared plus 25. F of x is equal to the square root of negative x squared plus 25. Now that's our function. And we want to find our inverse function. So the first thing we do is change this to y. Square root of negative x squared plus 25. Now let's change the y and the x. And now let's solve. Well, the first thing to do to solve is you got to raise both sides to the what? 1/3 power. I meant to the third power, sorry. Or square. And you get x squared is equal to, what happens to the square root and the square? Cancel. Negative y squared plus 25. X squared minus 25. Divided by negative 1, usually, divided by negative 1. Now give you y squared is equal to negative x squared plus 25. And then take the square root of both sides. And y is equal to the square root of negative x squared plus 25. Well, what happened?
Same thing.
You get the same thing. And when you get the same thing, that means you have a one-to-one function. That means that the inverse of the function is the function. All right? And that's what happens when we do one of these. So the inverse function is the function. And that means it's a one-to-one function. What is a one-to-one function? Huh? Yep. And a one-to-one function basically means that you have a line or a curve or whatever, and you put a vertical line through it, and it's called the vertical line test. And if you put a vertical line through it and it only intersects at one place, that means it's a one-to-one function. So that one's a one-to-one function, and this one's a one-to-one function. It only crosses the line one time. That's a vertical line test. Okay? And that's what that implies right there. Okay? Let's go to another. Still want to get to a curve. There's the horizontal line test, I'm sorry. Horizontal line test and vertical line test. Let me tell you what the difference is. I'm sorry. The horizontal line test proves that it's a one-to-one. That means that anything crosses one time is a one-to-one function. The vertical line test basically tells that it is a function. My bad. Vertical line test is a function. A one-to-one is the horizontal line test. So make sure you make that distinction.
Vertical line.
That's back in chapter 1 or 2. It's a function.
Horizontal is one-to-one.
One-to-one function. Still haven't got to where I want to get. Not going to turn the page. Okay, you need to write this down. If you want to check to see if that vertical line, the horizontal line test, is how you check it graphically. If you want to check it algebraically, do F composed of G and G composed of F, and then if you get X for both, you've got a one-to-one function. And that's what that means right here. You need to write that down. To check algebraically, if there's an inverse function, and it's one-to-one, do F composed of G and G composed of F. And if you get the same thing, X, if you get X for the solution, then that means that you have an inverse function and it's a one-to-one function. They show you an example right here. Then we'll do one here in a minute. I still haven't got to where I want to get to because that's more important than all of this stuff, because you can do that without any problem. We're doing a lot of explanation right here. What I'll test you on to see if there's a one-to-one function or not. Let's see.
Check algebraically.
F of G and G of F. Okay, now we're getting into where? There we go. Here we go. There we go. All right, let's check this one. F of X is equal to the square root of X plus 5. F of X f of x is equal to the square root of x plus 5. All right, first of all, we know this is a graph and it looks square root of x plus 5 means it's got a horizontal shift of 5 to the what?
Left.
It looks something like that. Now, y is equal to square root of x plus 5. Change it. I'm about ready to go home. X is equal to the square root of y plus 5. Square both sides. And that goes out. X squared is equal to y plus 5. X squared minus 5 is equal to y. Now x squared minus 5 is going to be a parabola with what? A vertical shift of what?
Right.
Vertical shift down. 1, 2, 3, 4, 5. Now a lot of you say, well, Hubert, that don't look anything like a parabola. Yes, it does. What does that look like? Looks like a parabola on its side, doesn't it? And what does this look like? Do they look like the same parabola? Yes, they do. But then why doesn't this one look like a parabola on its side, which is called a hyperbola? The reason it doesn't is because you can't take the square root of what? Of a negative number. Negative 5. I mean, if you can't, this doesn't exist. Now, if you was to do it on your graphing calculator, and the first one is square root of x plus 5, square root of x plus 5. Can't find it. Where's the square root button? There it is. Square root of x plus 5. And then do the bottom one. What is it? X squared plus what? Now let's go back and take out this one. There's your square root. Now you could take the square root of a negative. I guess it's not going to let me do it. Hold on. Well, that's what it would look like if you could take the square root of a negative. And then graph the other one. I'm about ready to quit. The next one is, what was it, x squared? So you see, what is the horizontal shift? The horizontal shift is 5. What is the vertical shift? 5. Both of them are negative 5. And the parabola, these two parabolas are exactly the same, only this one don't have a bottom half because you can't take the square root of a negative number. So yes, it is the inverse function. Is the second one a 1-to-1? The first one's 1-to-1, but what about the second one? First one's 1 to 1 because it connects one time. But what about the second one? No, it's not 1 to 1.
Okay.
So let's check it algebraically.
When you say next one, you're using both of the lines where they,
Okay, the horizontal line test is not that difficult.
I'm not.
All right? Just draw a horizontal line. How many times is it connecting here? So it's not a 1-to-1 function. Draw another one. This one is connecting one time. Is that one a 1-to-1 function? Yes. So the first one is a 1-to-1. But the second one is not 1-to-1. Why? Because it connects twice. So you can use one line or you can use two. It doesn't matter. As long as you see that the square root function only connects once. The squared function connects twice. Any circle or parabola or anything that has something like this, anything like that, any parabola, any circle, any ellipse, any of those are not going to be a 1-to-1 function because they cross more than one.
I know you said it's not that hard, but when you drew the second one, isn't it actually touching like 3 times?
Two separate functions in that.
Yes, two separate functions. So this function is only once, this function right there is only, this one is only once, this one's twice. Still not exactly where I'm wanting to go, but it's getting there, so just hold on. I wanted to get one. Oh, what I wanted to show you is, let's check that one algebraically and see if it's 1-to-1. The first one was f of x is equal to the square root of what? X plus what? I don't know what's wrong with this line. And then the second one, f inverse of x is equal to x squared minus what? So we'll do, that's g of x. You can say this is g of x. Okay. So I'm going to do f composed of g, which means I'm going to draw f in terms of big sets of parentheses. Plug x squared minus 5 in there. And what's x squared minus 5 plus 5? What's negative 5 plus 5? And then what's the square root of x squared? Okay, so far that one looks okay. Let's do the other one. G composed of f. That means we've got to draw that one. X, parentheses squared minus 5. And then plug in x plus 5. Now here we got a problem. Oh, wait a minute, hold on. Square root of x plus 5. All right. What happens to the square root of x plus 5? That goes out, and you get x plus 5 minus 5, and what does that equal to? That means that the original function is a 1-to-1 because you got x. The original function is 1-to-1. And these two are inverses of each other. Because each one you got x.
On the x plus 5, it's just supposed to be x plus 5. Where did you do the square and get rid of the bracket?
The square, G, means you're going to write this in terms of big sets of parentheses. So, big set of parentheses squared minus 5. big set of parentheses squared minus 5. And what are we going to plug into it? Yeah, square root of x plus 5, and then that goes out. 5 minus 5 leaves x.
And both equal each other in one.
When these two equal x, it's got to equal x. Both of them's got to equal x. Then this is a one-to-one function. When did I sign out? A moment ago. I don't remember. This is really a pain. I mean, first Tri-County does it, and now this Pearson does it.
You still only have there.
Huh?
You still only have there.
Right here?
Yeah.
Well, then why did... Oh, Lord. Well, it's not letting me in. There it is. Sorry about that. I think we just did that one. All right, let's try this one. Don't know what it looks like, but let's try it. F of x is equal to 2x over x minus 1. F of x is equal to 2x over x minus 1. Y is equal to 2x over x minus 1. X is equal to 2y over y minus 1. So the first thing you're going to have to do is you're going to have to clear the fraction to do anything, because you can't do anything while you have a fraction. So multiply both sides by what? Y minus 1, or y minus 1 over 1. That clears. You got x times y minus 1 is equal to 2y. Well, this is a mess. Now, go ahead and distribute this and this, because you got to get the y's on one side. So you're going to have to distribute. So that's xy minus x is equal to 2y. Now you got it to where you can get the y's on one side. What do you need to do with that x? Move it over to the other side and move this 2y back over here. So xy minus 2y is equal to x. Now, what do you have in common here? Y. So factor out y, and that leaves you with x minus what? Is equal to x, and y is equal to x over x minus 2, or y inverse. Now, go ahead and check both of them. F composed of G, G composed of F, to see if they're one-to-one.
Negative one.
What?
Negative one.
Yeah, that's G of X. Yeah, you can say this is G of X.
So they don't equal each other, what do you do?
Hmm?
If they don't equal each other, what do you do?
If they don't equal X on both of them, then they're not a one-to-one function.
Let me bring you back to clarity when I come back.
Huh?
I can bring you to clarity when I come back.
No, I'm fine. It'll go away eventually. If not, I got some stuff at the house I'll take. Knock me out for 2 or 3 days.
I have taken anything else, not
No, thank you. I appreciate it. All right. So let's subtract, or I'm sorry, erase all of this. And I'll take this out. We'll call that G of X, which is usually means the inverse. So F composed of G means that I'm going to rewrite this in terms of parentheses. So that's 2 parentheses over parentheses minus 1, and then we're going to plug that in. X over X minus 2, X over X minus 2. Okay, now we have a big mess. So I'm going to multiply this over here. 2x over X minus 2 over X minus 2 minus 1. Now we have a complex rational expression. Complex rational expression means that we got to do some clearing. So what I'm going to do is I'm going to copy this and go to the next page. Probably won't let me copy it, but it did. Copy. And move to the next page. Okay, so here we go. Got this up here, and I'm going to rewrite everything as a fraction because that makes things easier. 2x over x minus 2 over x minus 2 minus x minus 2 over x minus 2. Now, since this is the common denominator of x minus 2, can I go ahead and do this up top? Yes, but I have to make sure I distribute that negative, right? Because technically that negative is right here, like that. So, 2x over x minus 2 over x minus x plus 2 over x minus 2. And what happens to the x's? They go out, Hubert. That's right, class. So I get 2x over x minus 2 divided by 2 over x minus 2. And what do I have? A fraction divided by a fraction. What do I do when I divide a fraction by a fraction? So I'm going to multiply by x minus 2 over 2. And the x minus 2, look there. What happens to the 2's? And what are you left with? So the first one, we have x. All right, everybody got that? So let's go back to the other one. G composed of F. Parentheses over parentheses minus 2. Parentheses over parentheses minus 2. And then we're going to plug in 2x over x minus 1. That's going to give us 2x over x minus 1 over 2x over x minus 1 minus 2 x minus 1 over x minus 1 What's x minus 1 over x minus 1? 1. What's 2 times 1? 2. Okay, so I haven't changed anything. So, we got 2x over x minus 1 over 2x minus this distribute this 2, we get 2x over x minus 1 over, what's 2x minus 2x? So you get that negative 2 times negative 1 is what? 2 over x minus 1? Yeah, that's what we're fixing to do. Good job. X minus 1 over 2. And what are we left with? And you feel good about yourself. So it's a 1-to-1. This is all algebra 2 stuff. You didn't learn it, that means 1, you're a failure, or 2, your teacher was a failure. And we all know whose fault it was. Whose fault was it? The teacher's. And then it was Bush's. Alright, let's try nerd. Because we're still checking to see if they're 1 to 1. Let's see what they got.
So it was 1 to 1?
It was 1 to 1 because each one of them are equal to x. Okay, they just checked to see if it had inverse. The rational, okay, see, they told you it's 1 to 1, so they didn't have to check it. We checked it just for the drill and to make you feel, you know, not very confident, to discourage you.
Really?
Sorry about that. Anybody know what page we were on? Were we on 312? 3 what?
345.
Well, that's 336. How could it be the 325? Oh, good.
We need to figure out how to pull that.
I know, it's a pain in the butt. Well, it won't even let me. This is a conspiracy. It's all Bush's fault. Okay, this is homework.
Yeah, we're too far.
That's not what I want.
Boogie. I think it's 338. Boogie.
Is it 338?
Yeah. Or 339.
Oh, 340 is good enough.
Yeah, it's past that.
Okay, there's one. There's one I'm looking. That's what I've been looking for right there. All right. Let's do C. F of x is equal to x minus 2 to the third power. F of x minus 2 to the third power. F of x equal x minus 2 to the third power. All right, somebody tell me what it looks like. It's a squiggly, but it has a horizontal shift of what? 1, 2, so it looks something like that. So y is equal to x minus 2 to the third power. X is equal to y minus 2 to the third power. Now what? What's the easiest thing to do? There you go. But those of you that don't want to quit, what do? Go to sleep. Okay? You don't want to drink first. You take a shot, you know.
Hey, that actually helps.
I know, it helps you study, right? Take the cube root of both sides. And that gives you the cube root of x is equal to y minus 2. And now what? Add 2, Hubert. That's right, class. Now, graph that one. Well, let's go ahead and graph both of them on the handy calculator. All right, the first one is square root of x minus 2, so that'd be parentheses, x minus 2 close parentheses, quantity squared.
Is it cube?
Cube, thank you. And the next one is the square root, the cube root, and I'm going to say x to the 1/3 power, x to the 1/3 power, and then plus 2. Graph. Oh, we didn't go to the right, sorry. I messed up. This needs to be over. I went the wrong way. That's horizontal shift 2 to the right. 1, 2. And the other one is on its side, and it's going like this. Now, the whole point, of course, mine's not drawn exactly like it should be, but the whole point is you should realize that right around here, what do you see? What should you see? Might be better to bring up the graph. There, that looks better. What do you see right around here?
Across the board.
Yeah, they intersect, that's true.
An open area.
Huh?
Open area.
Yeah, that's true, but you're both wrong. What do you see? I tell you what, let's blow it up.
Walked-in area.
Yeah, y'all missing the whole train. Y'all not missing the car. Y'all missing the whole train. Y'all suck.
At least we're jumping.
No, you're not doing anything. Getting it wrong. Oh,
We're trying.
I don't even know. Trying don't mean squat.
People
Whatever.
that don't try, people are really trying.
You know what trying will get you? Blown up with a hand grenade.
Well,
All right.
Well, you know what? Albert Einstein tried a bunch of stuff.
Whatever.
He still tried.
Whatever.
He didn't just
Trying. He failed 2,000 times. All right. Look at it. What do you see?
Looks like a
Arrow?
What?
Arrow?
Little strings go over the neck. And then her teeth here.
How about they look similar?
She's got that.
How about they look like the reflection of each other?
That too.
Oh, yeah.
Oh.
I was gonna say it was our.
Dang old, hold on. Y is equal to dang old X. Dang old, what does that look like? Look kind of like flip-flop each other? That's what you're supposed to be seeing. You can't see it very much with the, remember the problem we did where it was like this, and one was like this, and the other one was like this? All right, you can't see it very well there. And you can't see it very well with the problem that looked like this. You can't see it very well with that one. But here, you can see what the inverse function actually does. What does it do? It gives you the symmetrical other what? Half. That's what it does. And that's why I was trying to get to this, to show you that this distance right here is the same as that distance right there. This distance right here is the same as that distance right there. And one other trick, if you was to graph these separately, is this a one-to-one function? Yes or no? Yes. Is this a one-to-one function?
Yep.
Yes, so they're both one-to-one. How do we check it algebraically? F composed of G and G composed of F, right? So let's do that. Well, you won't be practiced, so when I give it to you on a test, you won't just leave it blank, don't you? No, you'll probably do. Let's see. Parentheses, big sets of parentheses, minus 2 raised to the third power. And I'm going to plug in the cube root of x plus 3. Cube root of x plus 3.
Where did you get 3 from?
2. I don't know. I was decided to change the problem and did, you know, you're supposed to change horses in midstream. You think that's the way it goes? Always change horses in midstream?
Yep.
That's the best way to do things.
Sure is.
Now we got a plain mess, but we really have the cube root of x plus 2 minus 2, and what happens to the 2's? And what's the cube root of the cube root of x? What's the cube of the cube root of x? X. Now check G composed of f. That would be the cube root of a big set of parentheses plus 2. Plug that in. X minus 2 cubed. And what happens to the cubes?
Goes out.
The 2's go out and left with it.
Look.
So they're one-to-one function.
Isn't that funny?
That has nothing to do,
I was just saying.
nothing to do with what we're doing.
Just saying.
See, that's disappointing.
It does not look funny. I've been watching it the whole time.
All right, question, right, complaint.
Thank you for extending the homework again.
Whatever. Yeah, the 2 sections of homework, yeah. Heaven forbid it's 3.
You're right, heaven forbid.
Because if it was 3, y'all all be whining and crying that I give you too much homework. Make sure you make a note about this guy right here. We've already went over it. There's a good one right there. That goes into the homework. .2 exponential functions. Oh well, I guess I'll just call it a day. We'll go over that. We'll go over 5.2 next. Huh?
Logarithms after that?
Yeah, logarithms is after this.